Hello, my dear students. Welcome to the fifth lecture of electrostatic potential and capacitance. In this lecture, we will discuss the MCQ questions of dielectrics and polarization. So, the first question in the MTG fingertips book from this topic, that is question number 44. Which of the following is an example of polar molecule? So, O2, H2, N2, and HCl. So, oxygen, hydrogen, nitrogen, these are given, and another one is hydrochloric acid. So here if we just look at the first three, O2, H2 and N2, I think these are all that means not only these three, all four are diatomic molecules here. So but here in this particular case these are atomic type here, but this is only one which is heteroatomic. Here in this particular case atomic means that all these molecules are made up of single atom. And here in this particular case, if we just look at the molecular structure of this O2, that means O double bond here, H single bond, and here in this particular case, if we just look at the HCl, H here in this particular case, if we just take the electronegativity wise, so here chlorine will be more electronegative compared to hydrogen. Here in this particular case, the dipole moment we can check. So the direction of dipole moment here, it is generally, how do we indicate the direction of dipole moment? It will be from less electronegative atom to more electronegative atom. That means direction of dipole moment is generally from less electronegative atom to more electronegative atom. So here in this particular case, this particular molecule which will be having a dipole moment, clear? Here in this particular case, this particular molecule will be having a net dipole moment which is not equal to 0. But these three, as these are homoatomic, so always remember, if homoatomic molecules are there, that means they will be having a net dipole moment to be 0. Their net dipole moment will be always 0. Clear? So here HCl, so which of the following will be polar? So that means this hydrochloric acid, this will be a polar molecule. Clear? Remember from chemistry that we generally represent the dipole moment in term by the sign of mu. Here we generally represent the dipole moment by sign mu. Okay, so moving to next one, choose the correct statement. Clear? Here in question number 45, polar molecules have permanent electric dipole moment. Okay, so just now we have discussed that HCl is a polar molecule, so they must have a dipole moments. Okay, that is correct. Next, CO2 molecule is a polar molecule, so that means carbon dioxide. Here if we just draw the figure, so C double bond O double bond O. Clear? So that means here oxygen will be more electronegative as compared to carbon, so it will be, so that means the direction of dipole moment will be from less electronegative to more electronegative. So less electronegative to more electronegative, that means this dipole moment will be cancelling, this dipole moment will cancel this particular dipole moment. That means here in this particular case the net dipole moment will be 0. Clear? So that means carbon dioxide, this is not a polar molecule. Similarly, if we take water, so water here in this particular case, H here in H, so here we will take O. So that means here in this particular case H, and here it is double negative charge, so here it is positive. So that means here in this particular case as oxygen we can say it is more electronegative as compared to hydrogen, so that means the direction of dipole moment will be along this direction here, and here it is along this direction, and H, it is having some bond angle 104 0.5 something degree, like that. So that means these two dipole moments will not cancel each other. That means here this H2O molecule it will be a polar molecule. That means it will be having some dipole moment. So its dipole moment is not zero. That means it is a polar molecule. ये यहाँ पे एक polar molecule होगा. That means, but here it is saying that it's a non-polar molecule. That means it is also wrong. Then dipole field at large distance falls off as 1 upon r square. So we know that electric field due to an electric dipole, electric field due to an electric dipole at large distances, that means from this dipole to this one, if the distance is r, that means the electric field at the axial point will be will be 2 ap upon rq. So that means it how it is related, it is inversely related to rq. Or if we want to calculate at equatorial point, that means suppose if we take a dipole and if we want to calculate the electric field over here at this particular point P, so which will be situated at some distance, let it be r, then at that point the electric field at the equatorial point will comes out to be how much? Simply minus kp upon rq. That means here also at a equatorial point it is inversely related to rq. Clear? So that means here inverse square will not be the correct one. So that means this is also wrong. So correct statement means polar molecules have permanent electric dipole moment. That is correct. Next, in question number 46, dielectric constant for a metal. So what is the dielectric constant for a metal? So how will you calculate this dielectric constant? So generally it is calculated dielectric constant of any material, or what will be the force in any medium, force between charges or field inside a given medium. So that is generally calculated by taking a vacuum or free space as a reference. Clear? So here that means how will you calculate the ones? We know that electric field in vacuum upon electric field due to a charge in any given medium, what will be this ratio? So we know that suppose if we take a charge, let us consider a charge q. Clear? So and we want to calculate the electric field at a distance r from it. Clear? So here this distance is taken r and we want to calculate the electric field at point a over here. Then that electric field in free space, if it is free space or vacuum, so if it is vacuum, then here in this particular case it will be 1 upon 4 pi epsilon naught, it will be q upon r square. But suppose here in this particular case what we will do, we will take the same charge q, and suppose we will be taking one medium, we will be taking one medium and we will be placing it over here. Suppose this is one medium and which will be, see, this is the charge q. Clear? And we want to calculate at the same distance from the given charge at location a. Clear? At this particular point पे, just like the previous one. Clear? यहाँ पे जैसे हम लोग इलेक्ट्रिक फील्ड निकाल लेते हैं वैसे ही हम यहाँ पे इलेक्ट्रिक फील्ड निकालेंगे, बट द थिंग इज दैट डायलेक्ट्रिक कांस्टेंट ऑफ द गिवन मीडियम इज के. यहाँ पे ये बोला है कि ये जो मीडियम है इसका डायलेक्ट्रिक कांस्टेंट क्या है, ये के है. क्लियर? Okay, so fine, here in this particular case then electric field in the given medium will be 1 upon 4 pi epsilon q upon r square. तो इसका रिलेशन क्या होगा, मीडियम में जो इलेक्ट्रिक फील्ड नीचे यहाँ पे लिखा गया उसका वैल्यू कितना होगा, 1 upon 4 pi epsilon q upon r square. So q upon r square, q upon r square, 1 upon 4 pi, 1 upon 4 pi will get cancelled, so it will be epsilon divided by epsilon naught, and it will be nothing but e naught upon e will be equal to epsilon, it will be epsilon naught into epsilon r divided by epsilon naught. So finally these two will get cancelled, so it will be epsilon r, or we can write it k, dielectric constant of the given medium. So that means dielectric constant is nothing but E naught electric field in free space upon electric field in the given medium. Clear? Or we can say force between two charges in free space upon force between the two charges in the given medium. तो इनका रेशियो हमें क्या देगा, हमें डायलेक्ट्रिक कांस्टेंट का वैल्यू यहाँ पे बोलेगा। क्लियर। सो हियर इन दिस पर्टिकुलर केस इफ वी एज्यूम दिस मीडियम, ये जो मीडियम है यहाँ पे, इसको अगर हम एक कंडक्टिंग मीडियम, कंडक्टर, इसको कंडक्टर या फिर इसको जो मेटल अगर हम एज्यूम करेंगे, एज्यूम इट टू बी मेटल, देन हमें ये मालूम है कि तो अगर मान लो कि चार्ज यहाँ पे है यहाँ पे, तो देन नेट इलेक्ट्रिक फील्ड इनसाइड द कंडक्टर इज जीरो। क्लियर। इनसाइड द कंडक्टर ई इक्वल टू जीरो, इनसाइड अंदर में इलेक्ट्रिक फील्ड जीरो होगा। अंदर में अगर इलेक्ट्रिक फील्ड जीरो है तो ये वाला टर्म हमारा जीरो हो जाएगा। दैट मीन्स द वैल्यू ऑफ के विल बी इक्वल टू ई नॉट बाई जीरो। क्लियर। अगर हम इस मीडियम को हटा देंगे तो हमें फील्ड वहाँ पे मिलेगा, बट अगर हम कंडक्टर या फिर मेटल को इसके ये जो पॉइंट हम एक लेंगे, अगर कंडक्टिंग बॉडी या फिर मेटल के अंदर में लेंगे तो उसमें फील्ड तो जीरो होगा। दैट मीन्स द डायलेक्ट्रिक कांस्टेंट ए विल बी हाउ मच, इट विल बी इन्फिनिटी। समथिंग बाय जीरो इज इन्फिनिटी, दैट मीन्स डायलेक्ट्रिक कांस्टेंट का वैल्यू कितना होगा, इन्फिनिटी पे होगा। यस, ऑप्शन बी विल बी द करेक्ट वन। नेक्स्ट क्वेश्चन नंबर 47, when air is replaced by dielectric medium of constant k, the maximum force of attraction between the two charges separated by distance. Okay, so here in this particular case what it is like previous question, तो इसमें जो डायलेक्ट्रिक कांस्टेंट मीडियम का यहाँ पे बोल दिया है कि डायलेक्ट्रिक कांस्टेंट के है। क्लियर। तो एयर को रिप्लेस किया जा रहा है बाय ए मीडियम। क्लियर। एयर इज रिप्लेस्ड बाय ए मीडियम। क्लियर। अगर एयर को हम रिप्लेस करेंगे, मान लो कि यहाँ पे फोर्स बोला जा रहा है, सपोज विल टेक टू चार्जेस। क्लियर। दिस क्यू एंड दिस इज क्यू, सपोज दिस इज द सोर्स चार्ज एंड वी वांट टू फाइंड द फोर्स ऑफ रिपल्सन बिटवीन द टू चार्जेस, या फिर जो ये जो चार्ज क्यू है, स्मॉल क्यू, ये कितना फोर्स एक्सपीरियंस करेगा इस क्यू चार्ज के वजह से अगर दोनों के बीच में डिस्टेंस ऑफ सेपरेशन हुआ। आर देन दैट मीन्स इफ इट इज़ फ्री स्पेस, अगर यहाँ पे फ्री स्पेस, इफ इट इज़ फ्री स्पेस और इफ इट इज़ प्लेस्ड इन एयर, तो उस वाले पर्टिकुलर केस एयर का भी कुछ डायलेक्ट्रिक कांस्टेंट वैल्यू रहता है। तो मान लो कि हम इसको फ्री स्पेस लेते हैं, या फिर अप्रोक्सीमेटली के का वैल्यू यहाँ पे 1 ही लिया जाता है। क्लियर। सो फ्री स्पेस मतलब एफ नॉट विल बी इक्वल टू सिंपली 1/4 पाई एप्सिलॉन नॉट क्यू डिवाइडेड बाय r square, so that will be the value of force. Clear. And suppose here in this particular case what we'll be doing, we'll be taking the same system, इसी सिस्टम को हम यहाँ पे ले जाएंगे और इसी को हम यहाँ पे रख देते हैं और उनके बीच में यहाँ पे, so here in this particular case what we'll be doing, here we'll put, here what we'll do, we'll put a conducting medium, or not, here we'll do put a medium in between the two charges. Clear. ये जो दो चार्ज है यहाँ पे, इनके बीच में यहाँ पे एक मीडियम यहाँ पे रख दिया जा रहा है, दिस इज अ मीडियम। क्लियर। एंड these are the two charges which are present over here. Then right now the question is that if the distance of separation remains same, ये distance of separation मान लो कि वो r ही है। क्लियर। तो फाइनली डिस्टेंस ऑफ सेपरेशन r। क्लियर। तो अभी इनके बीच में फोर्स कितना होगा, तो फोर्स हम कैसे कैलकुलेट करेंगे, तो फोर्स विल बी नथिंग बट 1/4 पाई एप्सिलॉन सिंपली क्यू डिवाइडेड बाय r स्क्वायर। ओके, सो हियर इन दिस पर्टिकुलर केस इफ यू टेक द रेशियो ऑफ दिस टू, क्लियर, तो इन दोनों का रेशियो क्या होगा, सो इट विल बी एफ नॉट अपॉन एफ का वैल्यू जो होगा इट विल बी सिंपली के। अभी इससे पहले वाले केस में इसको ये रिलेशन हमें मिला था। क्लियर। दैट मीन्स ओवर हियर the force in the given medium will be nothing but f naught divided by k. Clear. So that means medium में जो force होगा, clear, उसका वैल्यू कितना होगा, जो जब मतलब जब मीडियम को हम रख देंगे, इफ़ यू रिप्लेस द एयर और वैक्यूम बाय a given medium, then the force, that means here we can decide if we replace the air or vacuum by a medium of k, particular k जिसका k ये डायलेक्ट्रिक कांस्टेंट है भी। क्लियर। देन the force inside will decrease by k times. Then the force between the charges in air or vacuum. क्लियर? तो ये डिक्रीज होगा, दैट मीन्स कितना टाइम, कितना ये डिक्रीज होगा, के टाइम्स, इट विल डिक्रीज बाय के टाइम्स. सो हियर इंक्रीज बाय के टाइम्स रिमेन्स अनचार्ज्ड, decrease by k times and increase by 2k times. So option C here, it will be the correct one.